today we have better alternatives. You will meet again Hibernate as open source ORM implementation, and you'll see how the project of Spring Data, one of the components of the large Spring framework, facilitates the access to different kinds of data stores. Just to talk about our alternatives, JPA nowadays means Jakarta Persistence API, formerly known as Java Persistence API. And what you have to know about it is that it is a specification and not an implementation. So you have some directives about what it is doing, how it is doing, but in order to do this, it needs to be backed by a persistence provider. We write here needs a persistence provider, and the persistence provider may be, of course, Hibernate. Not absolutely necessary, but nowadays Hibernate is the most popular ORM implementation in the Java world. You may have other alternatives like, for example, MyBatis, Eclipse Link. But anyway, you are going to address through JPA to one of these providers through the own API of JPA. We have Hibernate that most of you said that have already encountered. It has a native proprietary API. It is an independent framework. We have this possibility to back JPA. So we may say that it can be used together with other frameworks. And what is in our world more and more in use is Spring Data JPA. It is, as I was saying, it is a project belonging to the larger Spring Data umbrella. It provides some improved support for JPA-based data access layers. It wants to reduce the boilerplate code, and we are going to demonstrate exactly what it reduces and how it reduces. And you'll see that it creates implementations for the repository interfaces. So we would like to have an interface to address to the repository, to interact, in fact, with the database. And you'll see that Spring Data JPA is able to create such an implementation based on some minimal information. Let's go now to our code. And I prepared here a project that is addressing all our alternatives. We would like to interact with a database in a simple way. We are going to provide what we call an entity here. You see, we have some item, whatever it means. It has some information. It is a very, very simple class. But more than this, it is an entity. So by using this annotation, which you see here is a Java persistence annotation, it belongs to this javax.persistence package. We are telling it is a class, but not just any ordinary class. It has some correspondent in the database. So one object belonging to this class has a correspondence in some table in the database. What it needs is this ID field. We have a primary key on the side of the database that will need to uniquely identify that record. And we have this private long ID. We have to annotate it with this ID annotation. And from now on, the frameworks that we are going to use will know, yes, this is the primary key. But who is going to take care about the creation of this primary key? Not us as programmers, but you see here we have this generated value annotation that tells we are delegating the management of this primary key of this ID to the database itself. And it has this strategy generation type identity. So we don't care about creating it, but let's say you database should take care about it, and you are going to generate one ID whenever we will come with another item. What do we need more in order to interact with the database? If we use JPA, one of the alternatives, we need to provide some separate configuration. And we say here, this is the name of the persistence unit. So we have a persistence unit that is backed by Hibernate. I was telling that JPA is only the specification and not the implementation, and it is backed by Hibernate. What else? We need to tell how to interact with the database, and we need to provide here some configuration. Our demonstration is having MySQL as database. It has some URL of the database, some credentials to access the database, say Hibernate dialect, whatever, some configuration. Just to make some quick comparison, here commented, we have the alternative of the H2, just for you to see that it is pretty similar. Of course, you have to use the configuration that is appropriate for each database. What is important, and we would like to emphasize from now, is that these ORM tools, these ORM alternatives, JPA, Hibernate, Spring Data JPA, work a lot at the level of the configuration. It means that, for example, if you would like to migrate to some other database, what you will need to do will not be here at the level of the code, but at the level of the configuration. And it should be pretty accessible for you to migrate your application from one database to another one, saying, okay, now I no longer work with MySQL, I work with something else. Of course, I need to know and to load the driver, the URL, to have the credentials whatsoever. This is the configuration at the level of JPA. Of course, we act somehow similarly at the level of Hibernate. We also say, okay, let me tell you the driver, the URL of the database, credentials, how many connections maybe at some time, whatever I would like to do. So one of the advantages of using any of these ORM frameworks is that you take some burden from the side of the programmer, from the side of writing code, and isolate this configuration in some particular places. If you think about how we were able to do this with the help of JDBC API, which I was saying that it is the classical way to work with Java databases, there you need to open a connection at each step to write by hand the SQL query, that it may not be portable from one type of database to another type of database, and you need it to close the connection. Now, this burden of doing this boilerplate operations and generating the SQL is moved at the level of ORM. Let's see how it is happening at the level of Spring Data JPA. Here also we have some configuration, but we went more in the spirit of the contemporary Spring, and we made the configuration with the help of the Java code. We are telling some similar things, and we are telling something more. We will need this transaction manager. you will see that Spring Data JPA is able to do even more for us, and it will be able to manage transactions by itself. But in order to do this, we just have to introduce this JPA transaction manager and to provide here this list of bins to handle them to the Spring framework, and the Spring framework will know what to do with them. I was saying that the contemporary approach of the Spring framework is more in line with doing configuration with the help of the Java code. Of course, we can do it with the help of XML. This was done at the beginnings of the Spring frameworks. Nowadays, the configuration with Java code are more in use. Of course, these are kept separate from the code, the other code itself. The configuration and the business logic are separate. If you would like to change something, you will act only at the level of this configuration. And now, once we define the things, we would like to see how we are interacting with the database. We have here Hibernate Test, just to save and retrieve some item. What we are doing is to have this session factory created. This is part of the Hibernate API. What we need to do here is to start or begin a transaction by ourselves, create the item, persist it, commit the transaction by itself, then again, begin transaction, retrieve the item from the database, commit to the transaction, and do the checkings. So you see, there are some repetitive tasks. Let's see how this item Hibernate test works. We test that we have exactly one item in the database and that its content is item from Hibernate. Just a moment. You see here that we are able to follow what the framework did for us. Dropping the table, creating the table, inserting, selecting. This is according to our instructions from the configuration. You see here, say create. Whenever you start, you have to create the table from scratch, drop if it exists, and recreate. We said show SQL. So this means that we are able to follow here. It is interesting for us at the level of this demo to follow exactly how Hibernate is translating from this Java code, say persist, for example, to SQL queries. What it is really important, and we would like to emphasize that these queries may not be always the same ones. What will do Hibernate in order to generate these things? It will look at which dialect you are using. And we're saying here we are using MySQL, so please translate our Java instructions into code that is into queries that are compatible with the MySQL database. We have here this database. It is right here at our hand. I say we have inserted one item, info item from Hibernate ID 1. Remember, I was saying that we push the burden of generating these keys, these IDs, on the side of the database. Let's see how things look like in the case of JPA. We have here another test. Let me keep open this Test from Hibernate, and we are going to compare and contrast them. You see, here we have to work with an entity manager factory, entity manager. Here we have to work with a session factory, and we are going to create a session. So we have different APIs, but somehow similar ideas. We also have to begin the transaction by ourselves, persist the item, commit to the transaction, just like here. Begin transaction, persist the item, commit the transaction. And when retrieving this item, we are going to start another transaction, manage it by ourselves, commit it, and do some verifications by the end, some assertions. Let me run this. What you see here again is that the framework is taking care of generating the SQL code, the SQL queries. No matter if we are using Hibernate or JPA, we may instruct separately, not to mix these things with the code, about things about creating the database, about showing SQL, similar things. Let's have a look now into what happened here inside the database. We have this item. Our table changed its content. It says, instead of saying item from Hibernate, it says item from JPA, because this is what we did here. So we provided another message in order to have a good demonstration about what we are doing. These are two classical ways to work with the database. They are very much in use now. Just to compare and contrast them, if you have this choice, what should you do? Work with JPA, work with Hibernate. At this time, working with JPA may be more universal. And eventually, if you would like to do some change to be backed by some other provider than Hibernate, what we are doing here, that will be pretty easy. You just come here at the level of the configuration, you come with at the level of the imported classes from here, and say, okay, I will no longer need this. I will need, for example, my Batis, and you start to work with it. So it is more flexible from this point of view. On the other hand, for some more complicated things, some particular things, Hibernate is providing sometimes additional features that are not part of the JPA specification. So it may be also an option, but less flexible, of course. Let's have a look at our next approach. It is Spring Data JPA. And you see here, we introduced this item repository. I will go here back to these slides, and I will remind you what was written on the very last line on our presentation before we switched to the code. It says here, creates implementations for the repository interfaces. Let's see what this means. So this is a repository. A repository is something that addresses the database, that is able to interact with the database. How are we telling this? We have to extend this CRUD repository. CRUD repository is an interface provided by Spring Data JPA. It already comes with some methods: save all, find by ID, exist by ID, find all by ID, delete by ID, count, delete all. I think that the names of the methods are self-explanatory because they are already telling us what they are doing. But you may ask yourselves, are they doing anything? Because they are belonging to an interface. And methods in interface don't do anything yet, but they are just waiting to be implemented. Is it true here? Yes, but it is true in a very particular way. Say we are extending here CRUD repository, we are inheriting these methods. And once we are inheriting these methods, we say, okay, I can already do the most basic operations against the database. The classical CRUD operations, CRUD meaning create, read, update, delete. So this is something that you will always want to do with some item. No matter what type of item you have. You may have a person, you may have a book, you may have an animal, whatever. If you want to treat it like an entity, and if you want to make it arrive to the database, you will have to deal with this CRUD methods: save, find, whatever, delete. So that's why they are here. They are inherited. So the item repository will already know them, and it will come also find by info. If I read this method, I will understand from its name that yes, it is some method that is trying to find something from the item based on the info that we have here. What type of entities is this item repository managing? What type of entity the item repository is managing is told to us by the arguments of these generics. So what we're telling here is, I am a repository because I'm extending this CRUD repository interface from Spring Data. I am managing an item entity, and this item entity has an ID of type long. This is what we are telling to Spring Data. What will Spring Data do for us in exchange for being told this information? If we look here in this test, we see that we create some item. I will come back to this line 28 because it has its meaning here, but basically we need to create an item to save it, and then we may say, can you give me this? Let's compare with what was happening, for example, with item JPA test. No entity manager creation, no transaction management by ourselves, begin, commit, begin, commit. So this is a burden that is taken from the side of the developer and say, okay, from now on, I will try to do it myself. So the management of the transactions is at the level of Spring Data JPA. What do we need here? We need this item repository. We see that we don't create it by ourselves, but we are injecting, we are auto-wiring it. In order to do this, we need to have this annotation with extend with Spring extension. And we say this is the configuration. And Spring Data will browse the packages, will discover this item repository, and will use it, will auto-wire it. But what will it auto-wire? What will it inject? As long as this item repository is only an interface. Let's discover together this. I'm going to run this test now. It is doing something absolutely similar to what our previous tests with Spring, with the JPA and with Hibernate were doing. What do we have here? This is what this line 28 is printing. I'm asking myself, which is the class of this item repository? And you see, it is a proxy. What does it mean? What does proxy mean? Proxy means a substitute. So Spring Data JPA will see, okay, you have an item repository, it is extending CRUD repository, it is managing your items, but you cannot do this with an interface. So you have already told me that it is a repository managing an item, so it has those save, delete, find by ID methods. I know what it is about. I know that when you say find by ID, I will have to translate to select all from item where ID equals, and I will insert the parameter you are giving me. So I already know these things. I just needed from your side to specify that you are managing here an item having the ID of type long. And from here, I will be able to take the burden and to provide you all the boilerplate code that you were previously eventually writing. And Spring Data JPA will create this proxy class, this substitute class that is implementing this item repository. And in order to see it again, look, this is the class. And we'll say, okay, I will create the methods myself for save all, and so on. I will know how to create them, and you just have to create this item repository and to use it. Let's see if something was happening here in item from Spring Data JPA. We prove that it is working. Okay, what about this method find by info? This is a method that we have just added by ourselves. It was not originally in this CRUD repository. It is a newly added method. What will it do? Spring Data JPA will parse the name of this method based on some rules and some patterns. Say find by info, and it will understand, okay, you are looking for some info from this item, and you already have this info field here. So I will say, I will translate based on this name. I will understand what you are doing, And I will translate in select all from item where info equals this parameter. Info is not to be found in any entities, but by parsing the name of this method, you are going to obtain full support from the side of the Spring Data JPA. All you have to care is just to write the name of this method with a correct return type and correct argument. And it is on the side of the framework to take care of you. I was previously saying that Spring Data has improved support for JPA based data access layers. It reduces the boilerplate code. So this is exactly what we have just demonstrated, and it creates the implementations for the repository interfaces. You noticed that proxy class that we proved it was injected in our testing code. Now, it is the time for our next questions. Why isn't it? Okay, look at your phone. It is written here, and it is asking which of the following frameworks is just a specification and not an implementation. This is part of what we have just discussed. So please answer to this question. Okay, everyone knows that, yes, JPA is just a specification and not an implementation. And our next question. Which of the following frameworks creates implementations for the repository interfaces? Time's up. Great. You have correctly understood and followed our demonstrations. Let's go back to have some more. Here, you may ask yourselves what to use, when to use, why to use. And in order to answer to this question, I made here some tests, some benchmarks. I have here some Hibernate performance test. No more about one single item to work with, but depending on the configuration from here, we may have from 1,000. I tried from 1,000 to 50,000, 1,000, 5,000, 10, 20, 30, 40, 50,000 items. And I wanted to compare about the performances. What we are doing here, you see, you recognize from what we presented about session factory, session whatever, begin, session, commit. But now we have a list of how many items, how many I will specify here, 1,000. And I want to measure the time for insertion, for update, for retrieve, and for delete these items. Let me run this test. It lasts a little more than the one with one unique item, of course. You see here, insert execution time, update whatsoever. If I run here, JPA performance test, it has some similar structure. Let's make sure we are working on 1000 items. We are doing the same: create, update, retrieve, delete. Let's run this. Okay, just a moment. It is running. See here the results. These are milliseconds, so insert execution time is 2 seconds, 279. If we compare, have a look here, you see that they are pretty similar to the ones from pure Hibernate, from native Hibernate. There are minor differences, and of course, if we run things a few times, they may vary, but they are very much alike. If we try the same thing with Spring Data JPA, remember, we are using the repositories, no more transactions, the code is shortened. Let's see at the level of the performance. Execution time, we are interested also about execution time. Okay, you see already some differences. Here, it is much more. 3.5 compared with around 2 and something. 2 and a little. Here is already some difference. We were saying that, yes, Spring Data JPA is great, and I reiterate that it is great, that it is shortening our code. Just to have a look here once more about the fact that it is having this piece of code for the save retrieve item versus, for example, this piece of code for Hibernate versus this piece of code from here for the JPA. But it has come with some cost, with some additional overhead. We shouldn't be surprised because it comes with an intermediary layer. Maybe you heard about one pretty old saying in computer science that in software, any problem may be solved by introducing an additional indirection layer. And here, Spring Data JPA is another level of indirection. It comes on top of the provider and on top of the JPA, and it comes with its own API and with its own classes. If we want to look more here, just to let you know, I want to have a look at the dependencies. You see here some dependencies for Hibernate. Here we are for JPA, pretty similar here, but for Spring Data JPA, if I look here at the dependencies, I have much more because I need to come with these new packages. They needed to be added to our POM XML file here. It means here, you see, it means some more memory footprint that we need. So things come at a cost. We added these two dependencies. These two dependencies, in fact, mean a few packages added in the background. Everything comes at a cost. We would like to perform better, to write less code, but at least for the moment, we need to pay some price. It is not a surprise for us, but we wanted to see how much this price is. And you see here some benchmarks about insert execution times. You see that Hibernate and JPA, the graphics are practically overlapping, while this Spring Data JPA is a very steep curve. The same for update, same for retrieve execution, same for delete execution time. So we have to be aware of these costs. If you will ask, okay, should I use Spring Data JPA? I would say in most cases, you should consider using Spring Data JPA. When you shouldn't consider working with Spring Data JPA, when, for example, when performance is critical. In most projects, you are going to do very little insertions, not thousands and thousands as I demonstrated, a few at a time eventually. But you have to be aware of the fact, if you have a project where performance is critical, you may think about other alternatives, maybe not even use an ORM. You may downgrade, we may say, to the level of JDBC or to the level of working directly with the database, with the SQL, with stored procedures. But readability is really important. Nowadays, it is cheaper to buy some more hardware, for example, to improve performance than to buy some more developers. And if your code is shortened, it is more readable, is more maintainable, if it has all these advantages, it is a very good reason to think about Spring Data JPA. Not in absolutely any situation, but this is a good reason to think about it. Let's have a look at our next questions. And we are pretty close to finish. You see here, we have a question about the design pattern. It's a proxy. A proxy, as I was saying here, it's a proxy. It comes with a substitute. This class is generated as proxy under the control of Spring Data JPA. And one more question now. Which frameworks do overlap in terms of execution times? JPA and Hibernate overlap in terms of execution times. Let's have another look at this graphics. You see here, Hibernate and JPA. This is Spring Data JPA that has a steep curve of execution time. Okay, one more thing from my side. If you would like to get this code additionally to the recording that Alex will provide, you may find it here on my GitHub, here ORM performance. So this is the full code for our demonstrations today. So we are close to the end of our sessions. If you still have questions, I'm looking forward for them.
Okay, great. Thank you so much, Cătălin. Before we move on to the Q&A session, we have a huge request for you. So I've shared with everybody a link to a feedback form. It would really help us if you completed it, and because it allows us to improve our webinars, to decide on what other subjects we might create new webinars, and it's really helpful for us to improve the overall experience. So if you could just it doesn't take more than 30 seconds of your time to just complete the webinar and tell us what we did good, what we can do better, what subjects you'd like to hear more about. That would be really awesome. And other than that, let's move on to the Q&A session. So if anybody has a question or something they would like to get clarified, you can write in the chat, and then Cătălin will be able to answer.
Okay, no. Some message, but not a question. And I think, Georgia, that we agreed together that if performance is not critical, we should go by readability, simplicity, maintainability. No other questions, I think. Okay, so if that's very good. I think that means that you've managed to clarify everything for everyone. So like I said at the beginning of the webinar, we will soon be uploading the recording of this webinar, and I will also make sure to add to the follow-up email that we sent you a link to Cătălin's GitHub, just so that everybody has access to the code and can test it. And other than that, just again the request to complete the feedback form. So thank you very much, everybody, for taking part. Thank you very much, Cătălin. Thank you for your presentation, and we look forward to seeing you at our next webinars. Have a great rest of the day, everyone. Thank you for attending. Bye bye for now.